This is problem number 11 from chapter 5 in the kinetic energy section. A person doing a chin-up weighs 700 newtons, exclusive of the arms. During the first 25 centimeters of the lift, each arm exerts an upward force of 355 newtons on the torso. If the upward movement starts from rest, what is the person's velocity at that point? So we have the displacement is 0.25 meters, which we converted from the 25 centimeters up here. They tell us that the force is 355 newtons in each arm. So we want to get the total force in the upward direction, which is 355 newtons in the left arm plus 355 newtons in the right arm, which is 710 newtons. They tell us that the velocity initial is 0 meters per second. The weight is 700 newtons, which is downward, and we found that the force upward is 710 newtons. Here we have our equations for kinetic energy and work. We set those equal to each other, and we have the force times the displacement times the cosine of the angle equals 1/2 times the mass times velocity squared. And the force is the 710 newtons upward minus the 700 newtons downward times 0.25 meters times the cosine of the angle, and the angle is 0. The angle is 0 because the person's movement is only in the y direction. We set this equal to 1/2 times the weight over the gravitational force, which is 700 newtons divided by 9.8 meters per second squared, and then we multiply this times the velocity squared. We solve this and we get velocity squared equals 0.07 meters squared over second squared. And when we square root this, we get 0.265 meters per second. And this is positive because the person's movement is in the positive y direction. Here we have the units, and we have the joules equals newtons times meters, and this will equal kilograms times meters over second squared times meters, and then we have kilograms times meters squared over second squared. And then when you plug this in, your final units will be meters over seconds. Thank you.